Let's go to class.
Yeah.
Okay. Sorry, the network was kind of how to change the network source. Hopefully this one is stable. I have somebody complaining that analysis is difficult. Don't bother. We're still discussing concepts. Analysis is something that's practical, it's not theory. So by next class, actually after this class, you need to start downloading your software. Tell you which software to download or we'll be using. And so right now we are discussing just concepts because we will need them for our study. When we start applying them, we'll see how it means. So the next concept is the concept of normal distribution or distributions. Generally, in statistics, we have different distributions. So, among these distributions, we have the normal distribution, we have the T distribution, you have the uniform distribution, you have the Poisson distribution, bimodal distribution, and many others. But we may not necessarily go into all the different types of distribution here. We'll just mention one that is very, very vital for us at this particular stage, which is the normal distribution. So the normal distribution is a statistical distribution that describes the behavior of our data set around the mean, how our data behaves around the mean, which is the center. So that's what we call a normal distribution. And once we talk about the behavior, we are trying to examine whether the values are individual score are close to the center, which is the mean, or they're deviated, or they're instead concentrated on one end. If you're looking at the chart that we have, you'll see that the mean, which is this U, it's a Greek letter, I think they call it mu, is the center. So it stands for the mean. Now, this mean, as we move further away, the scores are reducing until maybe you get to, they never actually, this normal distribution never gets to 0. And if you look from, you see that we have 1 minus Q. That Q there stands for standard deviation. So for somebody who is saying, I believe you don't have the notes, madam. Okay. We have 1 minus Q and 1 plus Q. So the Q there stands for standard deviation. And what insinuates is that as we move away from the mean, which is the center, we have fewer and fewer scores. Now, there's what we call the standard deviation rule. The standard deviation rule says that 68% of our scores will fall between plus or minus 1 standard deviation. I'll give a simple example. Let's say we carry out a study of students, and the students there were 100 students in a class, just as an example. And the average score for the class is 12. Or let's say the average score is 10, right? For the 100 students. And the standard deviation, which we'll explain as we move further, is 2 or 1. Let's just say 1. So 68% of the students in that class will have their score between, if the average was 10, we'll have their score between 9 and 11. So the mean is 10, We subtract 1 from it, which is the standard deviation, to have 9, the lower limit. We add 1 to have 11, which is the upper limit, for the marks for 68% of the students. Then 95% of the students will have their score between +2 standard deviation. Standard deviation. What that means is that 95% of students in this class will have their score between 8 and what? And 12. So if you go to this class with a standard deviation of 1 and an average of 10, then 95% of the students will score their marks between 8 and 12. Now, any other student that scores are beyond this region is often considered as a little bit an outlier. So somebody who scored maybe 18 or 19 or 20 or 19 will consider you as what? An outlier, an extreme score. A score that significantly deviates from the rest of the score. So we consider it as an outlier. So now, the concept of standard deviation or normal distribution is very, very important in real world. Yes. What's this? What's standard deviation? Okay, standard deviation refers to the variation of individual scores from the mean. Now, let me put it this way. Let's say our mean is 10, right? For the particular exercise we have given, and somebody scored 3, right? There's a variation between the average score, which is the score that we're assuming that everybody would have scored, and the person's individual score, which is what? 10 minus 3 gives us 7, right? There's somebody who scores 6. The person's variation from the center score is what? 4. There's somebody who scored 10 on 10. So what's the person's variation? It's 0. Means the person is actually at the center. You have the same average. So that variation from the center is called the standard deviation. Now, at times, the definition of standard deviation is like I say it is the square root of variance, right? But I don't want to give you in terms of the definition in square root of variance, which we'll discuss that. But to put it in a real world scenario, that we're trying to look at how individual score differs from what? The center score, the normal expectation. If all the students were equally intelligent, right, everybody should score the same, which is 10. But there's some that are more intelligent, some that are less intelligent, even some that are very, very intelligent, some that are very dull. This is the actual reality of the class. But how far away are individual level of intelligence from what? The normal expected levels of intelligence is the concept of standard deviation. Is what the standard deviation captures. Is it clear? Or is still very much not making much sense? No, if you have not, I can try to explain again. Maybe I will borrow your mother tongue and try to explain it there. You can go back. Yes. Yes. Don't bother. Yes. Why are you in a haste? This is statistics. You're running. You see calculations. Right? Now, the fortunate thing is that we'll be using softwares and we may not go through that hard procedure of calculating manually, but then there is a way. Everything we're saying here, you do it. It's not imaginary. What we're discussing, don't think as we're singing. I'm even tired talking. But there's time that you'll be the one talking or struggling. I'll be looking and laughing. You get it? Just to say, this is something that is real. We'll see how that is done. So now, a good knowledge of the standard deviation and the mean helps you to calculate the proportion that can be affected whenever you take a decision. For instance, if you have discovered that the average of the class is very low and you have a standard deviation and you wanted to improve the average, you will use the standard deviation to know how many marks you want to add as a teacher, right? For instance, if the standard deviation is 2 and you wanted everybody to have at least a pass mark, you know that you should add maybe 2 to everybody to get to a certain level, right? That's the general expectation. It clear? So now let's try to explain the concept of normality in a real world scenario. When you go to an occasion, wedding, funeral, and birthdays, which fruit is often there? Fine error. Every occasion. If you go to every occasion, if they want to cook only one dish, what will they cook? They cook rice. Why? I didn't get you. Are you sure that's the reason? Okay, yes. They can be easy to cook, less costly, but if it was not easy to cook and people don't want to eat it, will you still go ahead and cook just because it's easy? Now, it has been proven over time that people are highly likely to eat rice. So rice become a normal food. When you're cooking rice, you're not asking if somebody will eat rice, right? Somebody said, I don't want to eat rice. But generally, everybody will highly likely eat rice. So rice is like normal food, right? After rice, you can now go to what? Okay, fine error becomes the second meal, right? If people don't eat rice, they should follow by what? Fine error. So in your occasion, rice first, followed by fine error. What again?
Fufu corn, sir.
Okay, somebody says fufu corn. Now, those are the top 3 meals. Imagine that you go to an occasion that they cook now. How do we call it now? Enkwa. I don't even know what enkwa is. Enkwa. No, not enkwa. Just one funny food. You have never heard of it. How many people eat? Okay, you taste more. Will you eat or you taste more? Now, we say that jokingly, but there's a concept to underscore. The standard normal distribution tells us how situations prevail in a real world scenario, uncontrolled scenario, right? Now, I also ask this question: why is it that all pens that you find will have this length, and maybe this somehow, especially this length? Why not have a pen that is as long as this? You think that's by mistake? It's not by mistake. They're using the concept of a normal scenario. So whether you have long or short hands, you should be able to use a pen of this length, right? There may be abnormal persons who want their pen to be double this size, but those are what? Outliers. So when something deviates from the normal, it becomes an outlier. You get it? Now, if you go to every occasion, you see that they will start by cooking the major dish that every people will eat. If you cook rice, cook your ekwa, and cook the whatsoever you have cooked, and most people come and they don't eat, what happens? It becomes strange, right? So it's an abnormal situation that people will come from an occasion and nobody eats rice. You get it? So if you're a businessman and you wanted to be able to do whatever you are doing, you want to know the average and the standard deviation, because it tells you, for instance, if you're a shoe seller and you're selling female shoes, at least adult female, if you wanted to buy, what should be the most common size that you should buy? Just give one figure. 38. You should buy 38, right? Because on average, most women who are of a certain age, adult women, their shoe size is what? 38, right? If you have a standard deviation of 1, so as a business person, the first most dominant size you buy is 38, followed by what? 37 and 39, right? Then 2 standard deviation will say we have 36 and 40. Anybody out of these 2 range becomes what? And abnormally. It'll be difficult for you to go and buy shoes, maybe buy, if you go and buy dominantly 41, how many women will buy? You are less likely to see out of 100 women, how many of them will buy? Maybe 2 or 1. You get it? That is an abnormal situation. So it's not within the confines of normal distribution. So in statistics, you always want your results to be what? Coming from a normal distribution. That's your expectation. Your data should come from a normal distribution, which means you are able to predict the proportion of people that will be affected, whatever intervention you are bringing in. You are able to know exactly that this decision I'm taking will affect this proportion of the people in this way, right? You affect this proportion in this way. In the way you are cooking rice, you are not bothered because you know everybody will eat. But if you are cooking a strange meal, you'll be worried that people may not eat the meal. It could be a very nice meal, but people may not eat because that's an abnormal situation. So when we analyze your data, you know it's normally distributed, you know you are very happy with your results. Because whatever decision you take is highly likely to be applicable. So the concept of a normal distribution is very important. And for us, we'll see how to calculate whether to check if our data is normally distributed. We'll see the different tests. For instance, we run what we call skewness, which tells us if data is not normally distributed, it can be skewed. Right? You all know about skewness, right? Back in school. It says skewness can be positive or negative. Yes. So now, before we even move on to talk about skewness, when your data is normally distributed, your mean, your median, and the mode, they are approximately the same. Your mean, the median, and the mode, they are approximately the same. We use the word approximate because they may be slightly different, right? But they are close to each other for a normal distribution. But when your data is not normally distributed, your mean, your median, and the mode, they will be different, significantly different. Now, when your mean is greater than the median and greater than the mode, we say that your data is positively skewed. In which case, we will have more scores below the mean. Now, I know that it gets a bit tricky for you to understand. Let's assume that our class average was we expected our average should be 10, but because the students are very intelligent, our average was 14, right? Instead of being 10, which is our normal expectation, right? So that means that if the data is normally distributed, the median should still be around 14. It can be 11, maybe it can be 13 or so, right? Now, if we arrange our scores from the least to the highest, we expect that our median should be around that 14. But if our median is around 10, then we say that our data is positively skewed. In which case, we have more scores. Now, to understand, if you calculate the salaries in Cameroon, especially of civil servants, you discover the salaries in Cameroon is positively skewed. Why? Because the ministers and most of these senators and the rest, one senator in Cameroon can be making 5 million per month, right? Although it's not the official salary, but benefits accrue, you make 5 million. Such that if you put the 36, I think Cameroon has how many ministers? I think around 36 ministries with 36 ministers and their deputies and the rest. Only what they take home can be 1 million, 100 million per month, just as an example. But if you combine almost the rest of the civil servants, they may not be able to make up to that 1 million, right? 100 million. Such that if you take the 100 million for 36 ministers and their deputies and take the rest of Cameroon and combine everything and put, it will show that the average salary of Cameroonian may be around 700,000 per month, right? But the reality on ground is that the average salary of Cameroonian, at least civil service, around 150,000 or let's say 200,000 to be fair. You get it? But because we have these ministers, they try to make it seem as if everybody's living large. We're living well. We're doing well. That's why whenever we are calculating the income, we use what we call the median income, because the median income is a better predictor rather than the mean. The mean is sensitive for outliers. You get it? Let's say we have 5 scores, 1, 2, 3, up to 5. What would be the mean? What's the mean? 1, 2, 3, up to 5. What's the mean? 2.5. Are you sure? The mean will be 3. If you add 1, 2, 3, up to 5, will give you 15. 15 divided by 5 gives you 3. What will be the median? Arrange them in the order of magnitude from lowest to highest. What will be the median? Median is the middle value. We will arrange in an order. What will be the median? Median will still be 3. But what if you remove 5 and put 10? What will be the mean? The median will increase to about 6 or 7. But what will be the median? Median will still be 3. Right? Why? Because the median is not sensitive to extreme values, but the mean is. And so, when we have extreme values, it either push up. If the extreme values are up, it takes up the median. If they are low, for instance, if we go to a class and the class average was 12, if a student scores 7, what will happen to a 12 class average? It will reduce to about maybe 10, right? Yes, because when we're adding a score and the score is above the average, it takes up the average. But if it's below the average, it does what? It brings down the average. So if this class average was 12 and somebody scores 7, the person may take the class average to around 8 or 9, right? But if the person came in with 17, it will take up the class average to around 15. So that's what happened with the mean. But the median remains fixed in a certain position. Now we'll see this in practice. So again, in sum, when your distribution is not normal, it means it is skewed. It can be positively skewed or negatively skewed. It is positively skewed when the median and the mode, they're all below what? The mean. It is negatively skewed when the mean is below the median and the mode. That's what we mean negatively skewed. In which case, we have more scores above the mean for negative skew, and for positive skew, we have more scores below. Is it clear? I should repeat the last statement. What was the last statement? I don't even know. When the mean is above the median, what happens? We said when the mean is above the median and the mode. Above here means greater. It is positively skewed. But when the mean is below the median and the mode, this is what? Negatively skewed. That's what I said. In which case, you see that the data is said to be not normally distributed. So, in a normal distribution, we explain that the data is symmetric. For a normal distribution, we say data is symmetric. Symmetric means we have equal proportions on both sides, right? So in a normal distribution, when the mean is the center, we have same number of proportions or scores below and same number of scores above. Let's say our mean of 10. So we may have 50 persons who will score below 10 and 50 persons who will score above 10, right? So that's a symmetric situation. But when it is skewed, we may have so many persons who scores above 10. That's now being negative because the mean is below the median. And when this is positive, we have so many persons that scores below 10, right? So people are scoring 6, 7, 8, 9, this and that. So that's the principle of normality, skewness, KTC, and we talk about being symmetric. Any question? So we can test for normality using skewness. We can test for normality using normality tests. We'll see them. Komologorov and Shapiro, we'll talk about them as we make progress when we're doing the application. We had already talked about inferential statistics and descriptive statistics, which we explained that inferential statistics describe the situation of our data. We respect the population, and descriptive focuses more on the sample, gives a summary view of the sample. So descriptive statistics is a term given to analysis to help describe or summarize data into a meaningful way. For example, identify patterns that emerge from the data. However, descriptive statistics does not allow us to make conclusions beyond the data. If you want to make conclusions beyond the data you have collected, you need to use inferential statistics. So, types of descriptive statistics. What are they? What are different types of descriptive statistics? Nobody's talking. Even when you have the notes, master. You have the notes. I've given you the notes. I'm giving you. I'm giving you exams. I'm giving you the answers. Then you don't want to even say it, master. Yes. So many attempts you want to, when you talk about descriptive statistics, you are doing a kind of examining the frequency of an item or a category, and you can also get the percentage. Frequency basically talks of how many number of times a particular category occurs. For instance, in this class, we may ask how many women are there, how many men are there, and you calculate it and get us the frequencies and the percentage. Now, for the measures of central tendency, we've said we call them averages. It describes the distribution of the data around the center. And when we talk of measures of central tendency, we are referring to the mean, the median, and the mode, right? Yes, so the mean, the median, and the mode. Again, it is very, very important for you to understand the concept of mean, median, and mode in application. The height of this pen is not by mistake, it's a standard, and that standard refers to the mean. The height of this door is not by mistake. It's most of the doors are around 2 meters, right? The height of the chairs, the size of football, standard football, all those things, they're produced using standards. Those standards are based on the mean. People only make variations based on the standard deviation now. You can know that, okay, if I increase the height of this pen a little bit, it may be inconvenient to some, but not many persons, so you increase, right? But most things around us are done using the mean, because the mean reflects the standard normal situation, right? When you want to cook food, you don't just carry salt and put. You want to put salt in a way that everybody will find it comfortable. That is the mean. There is an average salt that you put that the food will be okay for most of the people. A few persons may say, hey, this salt is small. Some may say it's much. You get it. But generally, most of the people should be able to say, okay, it is what? This will be normal. If that happens consistently, you're dealing with the average, because it applies to most of the people. And so most things around us are done based on averages. We say a screen, standard TV screen, they give different dimensions. if any company wants to produce, you don't just go now and create a new dimension. You try to get what? A standard. You may change the designs and everything, but still end up with maybe with that standard measurement. You get it? And the issue of standard gives a possibility to scale. You can mass produce only when you have a standard. You get it? It's difficult to mass produce when you're doing with custom design. So you mass produce when you know that this is a standard, and that standard reflects the mean or the normal situation. So a company that wants to produce shoes for men may not necessarily will just know that average size shoe size for men is this and do mass production, right? But if somebody comes out with special command 47, you cannot mass produce for such scenario. So the average is very, very important in real world. If you understand the concept of average and the standard deviation, you can run your business successfully without too much statistics or anything. You will discover that you will not get into shocks most often in the issues of life because you calculate the probability of it deviating. If you understand the concept of average and those who deal in the stock exchange, the standard deviation is for measurement of risks. If you come from the finances, you know that the standard deviation is used for measurement of risks. Why? Because it captures the variation from the average. Now, if you have been doing trading let's assume you're doing trading in American stock exchange, right? And you study average, you know that each day the market will go up by 2%, come down by 2%, go up 2%, come down by 2%. When market starts fluctuating higher, that's why you see that it may go up 5%, right? And come down 10%. There's fluctuation. So the risks become high and the standard deviation also increases. But when the standard deviation is relatively small and fixed, then you can always capture the risks involved in any deal you're working. So risk is measured using standard deviation because it tries to capture the variation that exists. Any question? Somebody's yawning, tired. Oh, the weather is hot. Eh? Is this weather cool? And I'm sweating. Online, any question? So, measures of variation gives you a sense of how spread out the response values are from the mean. And the common measures of variation are the range, the standard deviation, the variance. So we use them to measure our spread. The range is the difference between the maximum and the minimum. It captures the extreme scenarios, the extreme scores. In a class where the highest is 20 on 20 and the lowest is 1, the range is 19, which is the difference between what? The highest and the lowest. Now, in calculating standard deviation, we pass through variance. Variance is what normally measures the difference between individual scores and the mean. Variance is what measures that. But what happens is that when we have an average, take a simple example, an average of 5, or an average of 10, and somebody scores 8, right? The difference between that person and the average is -2. You get it? If somebody scored 12, the difference between the person and the mean is 2. If you wanted to get variation, we'll need to add the difference. So if you add -2 plus 2, what shows? We'll have 0. But then, does that mean that there's no variation from the mean? Because if variation is 0, it means everybody has the same, say, uniform distribution. Everybody has the same score. You get it? No, we're experiencing a variation. But why is our variation standard variance strength 0? It is because the negative influence of that negative influence. When we add negative and positive number, it tends to cancel out, right? So how statisticians solve this problem is that they square all the values to have what we call the absolute, right? So we square the negative 2 to become 4. We square the 2 to become 4. Now, what you witness is that when we are squaring a value, we always square with its measurement unit. You get it? So we square with the measurement unit. Such that the first challenge is that the measurement unit, if we are dealing with meters, become meter squared. You cannot compare variation of meters and meter squared because the measurement units are not the same. Remember I said we only do apples to apple comparison. You cannot do apples to oranges comparison, right? So you cannot be comparing something measured in meters squared and something measured in what? Meters. So you must either take everything to meters or you take everything to meter squared. So when you bring in that square root, it increases, or the squared, your unit of measurement is changed, and the values become significantly different from the real scores. Our scores were ending around 20, but if you go by the use of this squared, you may discover they will go above 20, and so will not reflect a true picture. That's why now we bring back the concept of standard deviation, which is the square root of our variance. When we square the variance, it gives us what we call the standard deviation. And so standard deviation is one of the most highly used measures of what? Spread or dispersion. Why mean is the highest use for a normal distribution. If your distribution is normally distributed, the mean and the standard deviation are the best measures of descriptive statistics to use. That's why most often when you hear the mean, you see beside it what? Standard deviation. A mean of 5 plus or minus 2 standard deviation. Be clear? Remember that. It's theory. You will get to application. I hope it will be easier. Now, other parts of descriptive statistics has to do with visualization, the use of graphs. So when you analyze your descriptive statistics, you always have to plot. And there are different types of charts. We can have bar charts, we have pie charts, we have histograms, you have box plot, and many other types of charts that you can find. So when we get to data visualization, we'll talk more about charts. But it's just important for you to know that there are charts that we'll see as we progress in our work. Anything we do, we'll be able to plot it. We have line charts, scatter plots, and many others. If you check, you'll see their samples, and so on and so forth. So the last but not the least concept that we'll take under this concept will be hypothesis testing. What's a hypothesis? Yes. It's a potential answer to a research question. It's a potential answer to a research question. Yes, that's good. Hypothesis is a potential answer to a research question. Right? Some people call it a tentative answer. Now, talking about research, what happens is that when you define your research problem or establish your research problem, the next important stage or the next important thing in that process is establishing what we call your research objectives. Your research objectives, we use them to bring our research questions. For instance, we talk about motivation, right? What is the impact of motivation? Or we want to determine the effect of motivation on performance. That is our objective. That objective can be converted into a research question such as what is the effect of what? Motivation on performance. And since that is a question, we cannot provide an answer that motivation has a positive effect on performance. So we come up with a question, we come up with a hypothesis, and we come up with objectives. That's the standard practice. Now, hypotheses are tested. And we use statistical tools to test hypotheses. Hypotheses are linked as form part of what we call inferential statistics. We use it to draw conclusions with respect to our data set on what is happening. And so, many a times when we want to generalize with respect to population, we have to test hypotheses. Now, if we choose a coin 10 times, as we said earlier, and something we can even do, we take a coin and we post it 10 times, anytime you note down the head or the tail, you either have 50-50 or 60 this, it will be alternating. Right? Yes. So the concept of hypothesis is, do I have enough evidence to say that what I've observed in this sample will reflect what will happen in my population? I always give an example about students who were disturbing in class and an exercise was given for them to perform. So 5 students disturbing in class, and I always like to give them names. What are the students saying? What are their names? Those who like disturbing. Right? Let's say we have 4. 4 is Paul. We have John, Peter, Andrew, and who? Stephen. Right? Yes. They're always sitting behind with deep voices. So what are you saying? So there is this experiment. It's not an experiment or but then that a teacher gave an exercise for 5 boys to do because we were disturbing in statistical class. And what he basically asked them was that they will need to go to the stream and fetch him water every day for 21 days. Yes. Every day for 21 days because we were disturbing. But not all of them will have to go to the stream. One person will go and carry water on the behalf of the others. And so after they just completed their statistical class, and in that class, they talk of the simple random probability sampling. They thought that for us to, and they were taught that the simple random sampling was the best form of selecting people without bias. So they were fascinated and they wanted to put into practice this principle. So they decided, okay, what we'll do is that we'll select each day, we'll come and do what we call sampling with replacement, which means you remove and put it back, right? You remove and put it back. So they said, okay, we'll write our names, right? Or we write numbers and put in a basket, 5 boys. And this proposal came from one of them. Let's just give the name as Peter. Says, we'll put all our names in a basket, our numbers in a basket. Each day, who will go to the stream and carry water after class is the person that picks number 1. So everybody says, yeah, right? It's a fair exercise, right? For 21 days, every day they come and do like that. So the first day, they come and they pick Stephen, being the unlucky person, so to say. Ballon, they say, this thing fall on your head, how they put it now? Maybe he's the person, okay, the first day, Stephen becomes the first person to go to the stream, right? The second day, let's say Paul. The third day, Henry. The fourth day, John. What's the expectation? Henry has carried, Stephen has carried, John has carried, Paul has carried. Who is left? Peter. Peter has not gone. And this proposal even came from Peter Massa. How do you feel? What's the emotion? What's the expectation? What's our expectation? Everyone should say something. What's our expectation? You don't have any expectation. Why? No, but the exercise says that is the person that picks number 1. So the fifth day, Paul, the sixth, John, what's happening? You start feeling that Peter should be cheating, right? But is Peter cheating? It's a fair game. We see every day. It's not like Peter comes and do the exercise. We are not there. At times we even come and we give somebody to shuffle it and Peter's name, everybody picks. Peter never picks 1. Right? 10 days gone. Peter has not been picked to go and carry water. Can we conclude that Peter is cheating? So we can't conclude that Peter is cheating, right? But we're increasingly feeling that Peter is cheating. Do you get it? We are feeling that Peter might be cheating, but we don't have any evidence to decide to condemn and conclude that Peter is cheating. 15 days. Everybody has carried around four times. Or some are 3, some are 4. Peter has not carried. What do we say? We have evidence that Peter is cheating, Abi? Yes. We are becoming frustrated. And we are thinking that Peter is cheating. So in statistics, what happens is that we talk about the confidence interval, we talk about hypothesis testing, we talk about the alpha level and the confidence interval and the significant level. These are all concepts that are vital to help us draw conclusion. Now, when we talk about the confidence interval, we basically say that it gives us the range of values for which we know that our population mean falls. I use the word population mean, not sample mean. You can always have the sample mean, but it will be difficult to have the population mean. So we estimate the population mean, right? Now, the sample, the significant, the p-value, or which is also known as the probability value, tells us the level for which we are either to accept or reject the null hypothesis. And in our situation of Peter and the friends, the null hypothesis is that Peter is not cheating. That's the null hypothesis, always a state of affairs by default. We don't think that Peter is cheating. But we're increasingly becoming frustrated and thinking that Peter is cheating, right? But then we need to get what we call enough evidence to conclude that Peter is cheating. The more we carry, the less likely Peter should not go to the stream, which means the chances of Peter going to the stream are increasing, right? The first day, there's no point. The second day, but 11 days, 18 days, you have not gone. No, it becomes near impossible. So after 18, maybe 19, we had 21 days. After 19 days, we say we have enough evidence to force Peter to go to the stream for the rest of the days. He's cheating. You get it? So in statistics, you set a confidence level for which you can conclude that your results are not by chance. That's what we are experiencing. From day 1 to day 19, we assume that was by chance that Peter has not taken. But after day 19, we don't want to go by chance. We say, okay, after day 18, we say, Peter, you carry for the rest of the 3 days. We can't continue to assume that you are being lucky. In statistics, we're saying that we have gotten enough evidence to draw our conclusion that Peter is cheating. That's the same thing that happens in a court, where you accuse somebody for anything. You have to go and bring proofs. Proofs means, and one each incident will not be enough, right? You need to bring enough evidence. So that's what happens. So in statistics, when you're testing a hypothesis, you are trying to evaluate and see to what extent you can say that what you have witnessed with this sample will replicate itself with the entire population set. And so you get to an extent, you say what we have witnessed It's a true reflection. We saw after 19 days, we say, Peter, you have been cheating, right? So we have enough evidence to conclude Peter is cheating. Before that level, we are giving him what? Benefit of doubt. We know that no, it's just by chance, by chance. But after a certain level, we say, no, you are cheating, right? So it's that concept of confidence interval hypothesis testing that basically helps us to understand what is happening in our data set. It helps us to draw conclusion. So we're taking what we have seen from the sample and inferencing it to the entire population using hypothesis testing. And that's where inferential statistics come in, giving us different statistical techniques to verify our hypothesis. We can have we have one sample t-test, independent sample t-test, we have chi-square, regression analysis, ANOVAs, and the rest, all available for us to test hypotheses about whatever we are doing. Any question? Any question? No question? So in sum, we have seen some key concepts that are vital for you to undertake. These are just a few, but they give you a general perspective to what we'll be discussing as we make progress. We'll see a lot more, but these are the fundamental concepts that are relevant for you to understand at this stage. The concept of a mean, the concept of descriptive statistics and inferential, the idea behind population and sample, how they relate together, and how they will influence you to draw conclusion, the idea of variables and their levels of measurement, and how they will interplay with analysis and OC, and then understanding the application of statistics in general. So that said, I believe that with this, we have some few terminologies, and our next class, which should be when tomorrow, our next class may need to engage into starting something more meaningful, which should be the use of computer. So we are expected to download the software and install in our machines. You have to download Anaconda. You have to download Anaconda. Go and type Anaconda online. Anaconda, ANACONDA, and download it and install. Anaconda is a Python, it's a data science, let me say, application that gives you all or most of the tools that you need to work as a data scientist in terms of IDEs, integrated working environment, or the user interface that gives you the possibility to work is. It will give you Python. It gives you all the libraries that you need. It gives you Jupyter Notebook, which are things that we'll see. So by tomorrow, we should be able to start basics of programming. We'll start basics of programming. We have many classes a week? 3 classes, right? So we'll take some days, we'll focus more on non-programming, where we're doing SPSS, and some days we'll focus on programming related exercise. So we'll use SPSS. When we're done with SPSS, we'll enter Power BI. So that's how our program will be structured. Programming, we'll have one day only for programming related exercise, and the other days we are taking for non-programming related applications like Excel. We'll be using Excel. We'll not do much in Excel, but we'll see. We'll use SPSS, use Power BI, and the rest. And so for tomorrow's class, either we take SPSS or we take Python, but try to download the Anaconda. And if you're online, you're expected to download Anaconda and at the same time also download SPSS. So any question for today? If no question, I think we come to the end of today's class. Our class continues tomorrow, 4 p.m. Please, if you've not legalized your studentship, try to do it, because from tomorrow. You are expected. We are going now into weightier things. And so you should do that so that they should not come and stop you when we are ongoing with our class. So thank you and see you tomorrow. Please, can you send me the link for the download? Just type the names online, please. Type Anaconda and SPSS. Just that the one you download, SPS you download online will be on Google. They will show you, they'll give you different links. You'll be able to get it. So thank you and see you tomorrow.